Hey guys, it's Anson here of Ada North Pole, and today a short video on Mithril stake-based threshold multi-signatures. Without further ado, let's get into it. So first I want to show the paper and a bit theory behind it. We won't go into all of the math, but of course the math is important to show and prove that it's secure and efficient. Without going too much into it, this is looks like a really cool technology, and I will try to explain a bit about that. So let's start with abstract. So in this work they make, they put forth a new stake-based primitive, or a stake-based threshold multi-signature, or STMs. So stake-based threshold and multi-signature, STM, or Mithril signatures. And this allows an aggregation of individual signatures into a compact multi-signature, provided in the stake that supports a given message, that it exceeds a threshold. That's why there's a stake-based threshold multi-signature. And this is different from just like having a threshold with, let's say, individual keys or identities. It is based on stake, so it doesn't need to know your identity. It just need to know how much, let's say, for example, Cardano you hold. And if a total of the voters that agreed to use the system pass a number of ADA for this threshold, then it is like everyone part of this stake-based threshold multi-signature have signed the message. And you can imagine that could be quite useful in many cases, and we'll get into that. And they show two use case examples. For example, in Bitcoin, without having to do any changes to the Bitcoin protocol, it can be used for people holding Bitcoin, not just miners, to basically agree or communicate or vote. And yeah, and I assume this could be quite easily then also transferred to other proof of work protocols. So that's quite exciting, and it can also be used in proof of stake, for example, to agree to, let's say, the blockchain information that you store in a database. You can come to a checkpoint. Okay, we're at epoch 350. All the previous history is such and such. We agree that this is true, and this can be very efficiently agreed upon by many actors with high stake in the protocol, so they have every reason to vote correctly and thus make it secure to use this checkpoint for your loading your information, such as for wallets, light wallets in particular, and let's say database management, DB-Sync maybe. Yeah, it has lots of use cases. So yeah, when I wrote this, when I read this research paper, I had some thoughts about it. But let's start with the basics. So there's a quorum of signers, so a group basically of SPOs. Not all of them have to vote. It's pseudo random, but if they reach this threshold, then it's like all of the SPOs have signed this message. The other important thing is that anyone can act independently to initiate a message, and then as long as you exceed this agreed threshold, then it's reached. So it doesn't have to be the same SPOs every time. Using SPOs as an example, and that's super useful. Just imagine like processes were not let's make it at an extreme example. So you want to do something with all of the 3,000 plus SPOs in the ecosystem. Okay, maybe not all of them are going to be online at the same time. So if you reach a threshold, let's say 75%, such as with the latest node upgrades, you want to have this threshold of 75% of all the ADA used for producing blocks. They need to sign this message, and then it's like you sign for all of them. And as you can see, then it's very useful that you don't need all of the different accounts to sign. You just need the threshold, because with so many people, it's impossible to sign off efficiently and quickly to gather all of those people at the same time. So for me, when I see this, that you can associate stake-based threshold multi-signature key to your cryptocurrency account as well, um, and that you can then make certify any specific message in a quality manner, then my mind started thinking, of course, voting is one thing. Let's say you want to vote between SPOs, but you can also like coordinate group behavior. I guess you could have this mega pool or a collaboration between, let's say it's an organization, ex SPOs that want to do something. Then you could probably also coordinate this with Mithril. Or let's say you have some data on the blockchain that you want to agree upon as an oracle. You could also use these SDMs to agree upon that data. So it could be used as an oracle aggregate, I assume. Um, and one of the key points is that it does this very efficiently. Let's scroll to the size of the proof. Let's see if I missed it. I guess we'll have to look through the pages individually. Let's see. Oh, here it is. So with this, and I hope I pronounce it correct, proofs, you could have a proof size as small as 4 kilobytes. And we know this matters. The smaller the files, the faster it propagates through the network, and the more efficient it is. So that's really impressive. Um, and a few more things I want to highlight before we leave the theory. So when it comes to this Bitcoin example, they actually show how this could be used right now in Bitcoin without having to update the code base or anything. So I found that pretty cool. And you can already use this for fast bootstrapping in proof of stake blockchains such as Cardano. Um, and we'll leave the article now because you can bootstrap basically if you want. There's an article on this. So if you go to mithril.network, and they're actively looking for SPO candidates to test Mithril, so please check them out if you like to test. And it's super easy. Get a preview network pool, get the faucet to give you some stake, and get a delegation. You need stake because this is a stake-based threshold, so not a signature. Get your pool up and running, then clone the Mithril client, super easy, git clone, setup, you need to set up a systemd service, simple, load the environmental file, and execute Mithril signer. And then the environmental file, you need your pool ID, network preview, export should be network magic 2, because that's the preview network, and you point to this aggregator endpoint, and this is for aggregating or agreeing upon the snapshot, and then how often it will run. This is the default. Point to the database directory of your preview Cardano network. Point to your node socket for preview network, to your Cardano node. Point to your Cardano cleave, and then, and this part is something that was a bit bugged in the previous release. I don't know if they fixed this, but before you had to manually create the data directory for Mithril data, or else it will throw an error when it started. I think they fixed this, but I'm just mentioning just in case. But you need to have a data storage directory created for the Mithril data that's created, these 4 kilobyte proofs. That's really Mithril. So again, we are a few of us SPOs are on the Mithril channel on the Discord. Go check them out. It's super easy to get going. Mithril.network. All right, that's all from me for this video.